Anna Dietrich is an industry recognized leader in the urban air mobility, eVTOL, and innovative personal aviation industries. eVTOL, EVTOL, stands for Electric Vertical Takeoff and Landing Aircraft. She is an expert in policy, certification, and government relations in the aviation industry, and generally solving complex problems in unique ways while inspiring innovation within a sustainable framework. Anna received both her BS and MS degrees in aerospace engineering from the Massachusetts Institute of Technology. Welcome, Anna.
Thank you.
Who or what inspired you to fly?
Well, I was inspired to go into aerospace engineering by my grandfather. He was, he spent his entire career in both military aviation and the space program, and worked on every manned spaceflight program that we had clear through the shuttle. So it was really just, an amazing experience growing up with his stories, growing up with model Mars landers in the basement. So there really wasn't ever a point when I was asked the question, what do you want to be when you grow up? When I didn't answer with an aerospace engineer. So really took a page out of his book. I got my pilot license in grad school and really did that in service of the engineering. So I had a goal from a very early age if I wanted to design, build, and fly my own thing. When I was in kindergarten and first grade, that was a spaceship that I wanted to design, build, and fly my own spaceship. But the reality of that sunk in before too long, and I decided to pivot that dream to airplanes. So I did ultimately get to do that. I did get to design, build, and fly my own airplane in the context of Terra Fugia. So I got the pilot license to be able to do the fly part of that goal.
Excellent. All right. Well, given all of that, then what or who inspired you to embrace sustainable aviation? And how did he or she do that?
I don't think that was any one particular person. I think as I've spent my whole career in the space of what I like to say, fun, weird things that fly. So it started with a roadable airplane. And as technology advanced and as the industry got more innovative, that expanded to include electric propulsion, both for conventional aircraft, as well as for the eVTOL aircraft revolution that we're seeing. Terra Fugia was one of the first companies, if not the first company, to publish a concept for a personal eVTOL aircraft. So really was at the very beginning of that conversation in many ways. And as we see how critical environmental consciousness is, and as the technology is advancing, and as we see the advantages that electric propulsion have for aviation, both in terms of not just the in-situ emissions, but the noise and the ability to perform new missions and increase safety through vehicle architecture and all of that. It really is just sort of the obvious place where we need to go as an industry, particularly for small aircraft and personal flight. So it wasn't really an epiphany or a specific inspiration, just really following the path of the innovation and the use cases that it enables.
We're hearing that it is necessary to have women involved in sustainable aviation. Tell us the various reasons why this is important now. Do women need a particular set of skills to achieve this? And could the 99s help in any way?
So I just, first of all, just thank you very much as an organization for making, women more visible in this space. My initial role model, of course, was my grandfather. I didn't know any women in aerospace in any sort of significant way until I actually got to college. So I really appreciate you guys raising the visibility for women pilots and women in the industry at large. In terms of specific skills or things like that, my undergrad class was almost 50-50 women and men. So I don't know that there's a specific thing that's lacking for women generally in terms of skill sets or education. I think that there is often, despite your efforts and despite the efforts of other organizations, I do feel like it's just sometimes a challenge to see that as a career path. I don't want to speak for sort of women more generally, but for myself, at least, I have found that there's a very strong desire to the sort of natural nurturing and caregiving extends to the planet and extends to taking care of the only earth that we have to call home. And I feel like that's sort of a natural connection to environmental consciousness and sustainability. And my field happens to be aviation. So that feeds very nicely into that, that sort of career path. I think there's also a lot of sort of people skills that often get overlooked within the aviation industry. And not that there aren't men that I know that aren't fantastic at that, but I do feel like for myself personally, the experiences that I've had as a woman have helped me to hone some of those interpersonal relationship skills in ways that maybe some of my male classmates weren't forced to do. I think that there's an opportunity to leverage some of that as well, and really build some of those bridges and make some of those connections. A lot of the women that I know in the space are very deeply connected with the certification landscape and with the regulatory environment, really at all levels. And I think that is something that I see a lot of women shining in that area. Not that I also know women that are pure technologists and pure engineers as well. But I think that sort of multidisciplinary approach and the connectivity to different disciplines and different people and the ability to multitask is something that, again, just speaking for myself, I hate to generalize too broadly, because I know that these skill sets are found kind of, many different people, but I know just in my personal experience that those are things that I feel like being a woman has kind of given me a little bit of a leg up on, and applying those in this space has been something that I've been able to do over the course of my career. So I think, you can find your path as a woman and kind of create your own path without, having to conform to what might otherwise be a fairly male dominant mold for how to act in this industry. And I think that that's something that younger women really need to keep in mind is, there's not one right way to do this. Like, you can be in this field, you can be an engineer, you can be involved in other aspects of the aviation industry, and still sort of be who you are and who you want to be, and not feel like you have to fit into some other, more masculine or other sort of preconceived notion, right? Like, create your own path and do your own thing, and find a way that it works for you. I think particularly as we start getting into more flexible working arrangements, it's one silver lining of COVID, is I think it drove home the fact that you really can be quite flexible with your working location and your working hours, and you can juggle more things personally and professionally and do them all just fine, all quite well. So I think that's something that maybe women approaching the field could take advantage of in the future as well, that additional flexibility that we built.
Excellent. Thank you. A marvelous summation, I must say. Thank you. I'm going to turn it over to Connie now. She has some different kind of questions.
Anna, you are one of the founders of CAMI, CAMI. Can you tell us a little bit about that organization and how it fits into sustainable aviation?
Sure. So CAMI is the Community Air Mobility Initiative, communityairmobility.org, for those that are interested in looking up more information online. And I started that with another woman by the name of Yolanka Wolf 3 years ago now, in 2019. And the two of us were really seeing a gap in the industry's engagement with local decision makers. So there was a lot of focus that was being put on working with federal regulators and with the Hill, but where this has to actually be integrated into our communities to have the maximum long-term benefit, no one was helping those people. So the transportation planners, the city zoning commissions, the local, state and local DOTs, those folks were really kind of being ignored. And for the revolution in aviation that we sort of see coming with the advanced air mobility and the increased electrification of aviation, that has to be integrated into our existing communities, into our existing society, in order to be really maximally beneficial. So CAMI, we started CAMI to support the integration of the third dimension into our local communities, to educate state and local decision makers about sustainable aviation, about eVTOL aircraft, and to really help them with the background information that they need to be empowered to ask good questions, sometimes hard questions of industry, and to build a transportation integration plan that includes aviation and that enables the electrification of aviation. As anyone has spent some time thinking about the field probably is well aware, these aircraft have to be charged. So the power has to come from somewhere. The grid has to get it to where these aircraft are operating, and it has to be generated in a way that is also sustainable. Flying an electric aircraft the electricity was generated from a dirty coal plant doesn't really help us out much. So we have to make sure that we're sustainably generating the electricity to power electric aviation as well, or we haven't really met our sustainability goals. So CAMI kind of takes that holistic picture, connecting the grid, connecting existing transit, connecting our communities to aviation, and helps those policy and decision makers figure out what to do with all of this. How do they approach all of this? So we're hoping to make it easier for aviation and particularly sustainable aviation to be integrated into our communities long term.
Wow, that's quite an accomplishment. Can you explain to some of the people who may not know what an eVTOL aircraft is, exactly what it is?
Yeah, absolutely. And that's one of the things that CAMI does is a lot of people come into this conversation and they didn't, how do you spell eVTOL, right? So it's an acronym, as is most things in aviation, eVTOL, Electric Vertical Takeoff and Landing Aircraft. So basically a helicopter is a VTOL aircraft, a vertical takeoff and landing aircraft. And all that means is that you don't have to have a big runway. You can just sort of take off and land in a spot, right? In a heliport or a vertiport, as we're calling them now for this new space in the industry. And the electric piece of it, you obviously could just take a helicopter and put an electric motor on it. But electric propulsion has a lot of advantages from an aircraft architecture perspective, in that it allows you to use what's called distributed propulsion. So you have multiple different battery packs, you have multiple different motors, you have multiple different propellers, and they're all working together to get the aircraft off the ground and to sustain flight. And what that means is if any one of those pieces fails, you still have all the rest of them. So instead of having a single engine airplane where if that engine goes out, now you've got a dead stick landing in front of you. One of these motors goes out, you still have multiple other ones, 3, 4, 5, 6, right? Like there's a much more a lot more redundancy in these aircraft configurations. So not only does that increase the safety of the aircraft and the redundancy for just safety of flight perspective, having this ability to have a smaller, more smaller propellers gives you some additional options in terms of noise. Electric motors are quieter than conventional powered aircraft engines. So you have some advantages in terms of making these aircraft quieter as well as safer. And that, of course, lets them kind of get them more integrated into our existing transportation and communities because they're friendlier. They don't make as much noise. They don't pollute. It's just a little bit of an easier integration task for an eVTOL aircraft. So eVTOL is just a fancy way of saying electric, and it goes up and down vertically instead of needing a full airport runway.
People probably wonder if eVTOLs are going to be able to take off from my backyard and fly me to my job or to my relative's house 40 miles away.
Yeah, so the backyard question is interesting. So there's still, basic physics involved. So there's still going to be downwash from the propellers, and there's still going to be safety considerations of not wanting people to kind of walk into the aircraft while it's taking off or landing and that kind of thing. So I do suspect that we will still have designated takeoff and landing locations primarily. Though you can get permission to land a helicopter on your yard today. So that's certainly something that is possible. But I think the vision that most people have is a distributed network of vertiports that are integrated with our existing transportation systems. So either at an existing airport or at a commuter rail station or at the parking garage downtown, that are getting you much closer to your neighbor's house, much closer to where you live, much closer to where you actually want to go. So instead of being, on average 20 minutes away from a general aviation airport, which is what most people are in the United States, you'd be on average 5 minutes away from a vertiport, right? So it just kind of gets you just that much closer to your takeoff and landing locations. But yeah, that's the idea. That range of about 40 miles up to about 100 miles, I think, is where most people are thinking in terms of these aircraft. But so city center, suburb access, edge city access, and then some rural connectivity as well. So providing some additional transportation options for folks that may not live near to educational or economic or medical opportunities, be able to connect them more directly into some of those advantages as well.
How will aircraft right-of-way be designated and administrated with all of these different types of aircraft flying up and down?
It's a really good question. And I would say it's one that the industry is still working with the regulator to solve. So there are a number of different possibilities on the table for entry into service for sort of the crawl phase of the industry. We don't really need to do anything differently than what we're currently doing right now for airspace access. So we already have air traffic control. We already have procedures that pilots use to interface with that system. So for the initial sort of entry into service, smaller volumes that we're imagining when we get started with all of this, we can just use that. As we get into larger volumes and more complex airspace with multiple vertiport networks and downtown operations and connecting into existing commercial traffic and things like that, that's when we start having to get a little bit more creative. So there's a possibility of doing a vehicle-to-vehicle self-deconfliction. There's the possibility of working within specific routes for urban air mobility aircraft, similar to how you'd have a VFR corridor in somewhere like New York today. You could have a UAM corridor where that's on your sectional charts and other traffic just kind of stays away. And then there's, eventually sort of the technical holy grail of a technical solution to a detect and avoid system that would effectively be able to replace the human sense and avoid that we rely on with pilot eyeballs today, so that the aircraft can just truly integrate into the airspace like any other aircraft today does. So there's a lot of options, a lot of layers to that. And I think, just like when we introduced automobiles, we didn't have interstate highways, right? We had little country roads that didn't even have sidewalks. And eventually we added sidewalks and we added lane dividers and we added stop signs, and sort of we organically built the infrastructure around the vehicles as they were integrated. I suspect there'll be some level of sort of organic development that happens too. So it's good to plan, it's good to try to get ahead of it. But I think ultimately we'll have a gradual entry into service and we'll be able to sort of organically solve some of these problems as we go.
Let's talk about autonomy and the future of aviation. Will these aircraft be piloted by people, or will they eventually become computer piloted?
I think the answer is actually yes, but I think we're talking about putting the pilot at a ground control station instead of on board the aircraft for the longer term vision. So there's very few, if any, players in the space that are intending to fully remove a human from the operations of these aircraft, but we are significantly working to redefine the role of that human. So one of the projects that I'm working with is X-Wing. They're developing an autonomy retrofit to a Cessna Grand Caravan, which is the most common aircraft used for cargo feeder flights, like with UPS and FedEx. And the vision there is that you'd have a ground control station where you have a human pilot that is operating the autonomous aircraft from gate to gate, from takeoff to landing. But then once that aircraft has gotten to its destination airport and is now kind of in the hands of the ground crew that's loading and unloading boxes, while that's happening, they're going to go look at another aircraft. They're going to go operate another aircraft from a completely different airport. So the human is no longer forced to be physically present with the airplane. And that has, makes a lot of things easier from a logistics perspective. So there's still a human monitoring that aircraft, operating that aircraft as it's flying, but not on board the aircraft. So I think that's, one sort of cargo use case, but even the taxi, the urban air mobility taxi operations, I think have a similar vision where ultimately you have a ground control station or a mission control center where you have people monitoring and operating the fleet of aircraft that are in service at any given time. So you're not taking the person away and having it just be up to the computer, but you are letting humans do what humans do really well, which is oversee and do high level decision making, and letting computers do what computers do really well, which is stick and rudder control and navigation and sort of what we let our autopilots do today anyway. So just a different sort of interaction between the human and the aircraft, but still a human involved.
A lot of people kind of poo-pooed the coming of electric aviation, saying that we don't have enough electricity to charge all of these aircraft. And where are we going to get it from? And what's going to happen to the batteries when they have to be disposed of? Isn't that going to be just as polluting as fossil fuels?
Yeah. So I would say in terms of the generation challenge, I would say that at least, in places like where I am in California, it's not a generation capacity challenge, it's a storage capacity challenge. So we have a lot of renewable generation capacity, but you need to be able to provide that electricity when you need it. So there has to be a storage solution to accompany the renewable generation. There is going to be a challenge in terms of grid build out to make sure we can get that electricity to the places where we need it to charge these aircraft. But it's not a new and novel problem. That's just we need to actually work on our power grid. We should do that for other reasons anyway. So I don't know that that's certainly not a like barrier, right? It may be a challenge that has to be addressed, but it's not a reason to not do it. From the battery life cycle perspective, that's a point that we talk about a lot with CAMI. And I think it's actually the problem of battery disposal is actually the potential solution to the sustainable energy storage problem. So the life cycle of the battery, only the first little bit of it is what most aircraft designers are planning to use for energy storage on board the aircraft. And then once the performance of those cells degrades a bit, then it's no longer really capable of, being the onboard energy storage for the aircraft. It's the storage to weight starts to degrade. So at that point, those battery packs can come off the aircraft. They still have an awful lot of useful life left in them, just not for flight operations. So those battery packs now can go into vertiport, on-site vertiport power storage or microgrid resiliency for our communities in general to store that renewable energy when it's being produced at surplus to be used when, at night when the sun isn't out or something like that. So I think we can not just recycle, but really repurpose a lot of the batteries that are on these aircraft that are coming off to help grow our ground-based storage capacity. So that's kind of not a full solution, but I think there's an opportunity there that we can maybe solve two problems at the same time, right? Like use the battery repurposing for the energy storage issue.
Anna, can you tell us what work opportunities advanced air mobility will be offering to women?
Well, I think there's a lot of work opportunities just in general that are, available to anyone who's interested. So I think there's a lot to be done on the technical development still. Battery technology is, as you were just talking about, a huge piece of all of this. And I think there is still room for disruptive innovation in battery technology. There's also a lot to be done on the autonomy and the certification of those systems. So to the extent that autonomy and sustainability are connected, there's a lot of good engineering to be done there. There's also an awful lot of certification and regulatory work to do. That's kind of my focus area, and that involves a lot of politics in many ways, because the human risk tolerance is a central aspect of the certification landscape that often doesn't get the airtime that it deserves, but it's a really central piece. And then I think, this integration piece that CAMI is trying to help local decision makers with of how do you integrate aviation into our daily lives in our daily transportation needs in a way that has never really been done before. Aviation's always been this thing apart. You drive to the airport, you park your car, you go through security, and now you're in the aviation world. You fly somewhere and then you do it all in reverse, right? So I think that there's a lot of opportunities for more closely connecting aviation to our existing transportation needs as well. So those are sort of the formative pieces of all of this. And then of course, we're gonna need maintainers. There's already a critical shortage of maintainers. We're gonna need pilots and remote operators. There's already a critical shortage of pilots. So I think, and then there's the whole economic engine of having a vertiport placed somewhere, of all of the supporting, ground-based, helping with passengers, helping with the aircraft themselves, all of that sort of gate operations that we see at commercial airports today. We'll have to do that for vertiports too. So there's an awful lot of ways that you can engage with this both today and then in the future as it starts to go into service.
Can you tell us a little bit about your role working with federal agencies like NASA and the FAA? How do you work with them?
Very collaboratively. No,
That's good.
so both FAA and NASA have really interesting roles to play in this space. NASA is, of course, the research institution, and FAA is the regulator. But there's a lot of work to be done on both sides. So I have worked with NASA to help structure their research priorities, I guess you could say, of where do we still have unanswered questions as an industry that need to flow into requirements definition, what data needs to be collected, how do we support communities. Part of the grand challenge that NASA is doing for advanced air mobility has included a community annex that CAMI has participated in. So there's a lot of sort of NASA's looking a little bit farther future, like what are the big questions that we still have to answer? What information do we need? Kind of conceptually, how do we do all of this? And then FAA as the regulator, that interaction, really working with the FAA in their regulatory capacity of what are the existing, CFRs, Code of Federal Regulations that we have to use? What are the existing means of compliance documents, industry standards that are appropriate here? Where are there gaps? Where do we need to do regulatory relief through petition and exemption? Where do we need to start rulemaking efforts? Where do we need to write custom means of compliance? How do we work with each applicant to kind of meet them where they are with the technology and figure out what the appropriate level of safety is that would be applied to this project? So everything that the FAA does it hinges on this idea of a safety continuum, that there's a varying degrees of societally acceptable risk based on what it is that you're doing. So model aircraft, you're flying little SUAS down on one side, you can tolerate more risk for those than you can for your commercial airliner that's flying people commercially, hundreds at a time every day. So that concept of a safety continuum and where do these new technologies fit into that is something that I work with the FAA on as well. So it's different roles of those two agencies, both very essential to getting to success here. And I think, it's important to remember as industry that everybody that's involved with both of those agencies, but, particularly with FAA, is there, we have the absolute best of intentions. We've built the safest transportation system in the world with aviation and with the FAA support. And we want to continue that, right? So having a collaborative mindset, having a sort of teamwork mindset, and pushing them to consider new technologies, but in a way that really retains that appropriate level of safety and that appropriate connection to that safety continuum that we've built over the years, I think is really important. So I see the FAA as an ally here. We're all trying to solve the same problem, trying to increase the utility of aviation and maintain, if not increase, the safety of it as well. So it's an interesting time when you're innovating with the regulator, but it can be a lot of fun, actually.
And my last question, are there any eVTOLs now that are certified and flying?
None have gone through type certification. There are quite a number that are doing full-size flight testing and are in various stages of the certification process. So there's, it's real. They're out there. They're happening. They are working through the certification, flight testing, working through prototyping and conforming prototypes and all of those progressions. And there's a handful of companies that are really quite serious and quite close to really having an entry into service product. But no one has been type certificated yet. But I do expect that we'll start to see some of those victories, and it'll be a victory for industry and FAA to have figured out how to navigate that process, right? So it is a very collaborative exercise. But no, hopefully we'll be seeing some of those in the next couple of years.
How many years? I didn't quite hear that.
Probably 2 to 3.
Okay.
Maybe a little sooner.
So are you talking just the USA? Is there anything going on in the rest of the world?
My greatest familiarity is with the U.S. landscape and with American companies, but there are key players elsewhere in the world. EASA, the European Aviation Agency, has been very active in this space as well, generating new special conditions for VTOL aircraft and working with manufacturers there. So they're very active other places in the world as well. But my most of my personal experience is US based.
Will we see eVTOLs flying in LA soon?
I don't know. LA is going to be a challenging entry into service market just because it's so complicated from an airspace perspective and other reasons. But yeah, I think commercial applications in that sort of crawl stage. It's coming. It'll be here sooner than we think. I think as in general, we tend to underestimate what we can do long term and overestimate what we can do short term. So I think we will see kind of more ubiquitous use cases of all of this sooner than we think, but it may take us a little bit longer than we'd like to get started.
It sounds like a brave new world out there. That concludes my questions. Sarah, do you have anything more?
One last question. Anna, if you could give your 18-year-old self advice, what would it be?
Oh gosh. The first thing that popped to mind was, would it be okay to go to law school? That was the other thing that I wanted to do. Was torn between engineering and law. But in the end, I've combined them rather nicely. So I don't know that I would actually want to change that path. I guess just that it all works out in the end, and don't be afraid to take the risks. Believe in yourself. And I think that probably goes for most 18-year-olds out there. Believe in yourself, work hard, and it works out.
Excellent. Excellent. Thank you.
Thank you, everybody. We've been talking to Anna Dietrich, one of the founders of CAMI. We thank her for coming and sharing her thoughts with us today, and hope all of you will become interested in sustainable aviation.